Hello and welcome to my science tutorials. In this video, we want to look at some few objective questions on work, energy and power in physics. Right, so we have here an example. So we have an object of mass 0.5 kilogram is thrown vertically up with a velocity of 30 meters per second. We have to calculate its potential energy at the maximum height, given that the gravity is 10 meters per second squared. Now, this is the SSC 1995 question number 15. And then here are our possible choice to select from. We have A, 150 joules, B, 225 joules, C, 450 joules, and then D, 900 joules. Right, so let's proceed to look at the solution to this problem. Now, the first thing we'll do is to write down the parameters that we have. So we have here an object of mass 0.5 kilogram. So our mass is 0.5 kilogram, and kilogram is the standard unit. So there's no need we do any conversion. But this has been thrown vertically upward with a velocity of 30 meters per second, right? So our initial velocity given to us is 30 meters per second. Are we okay? Remember, this was thrown upward. Okay, so it's very necessary. We have to calculate the potential energy. So we have to find the potential energy, which we do not know at the maximum height. So we need to find the height first if we want to find the potential energy. And then we've been given gravity to be 10 meters per second squared. Okay, now to find the potential energy is equal to mass times gravity multiplied by the height. Now, the height we don't know, the gravity we have, mass we have. So the first thing we need to do is to find the height. And to find the height, we are going to use the formula v squared equals u squared minus 2gh. Okay, now this is not plus, it is minus because the stone has been the object has been thrown upward, so it is working against gravity. That is how come it is negative. If it were to be coming down, the negative here will become positive. Are we okay? Now, because it has been sent upward or thrown upward, it means it has initial velocity and not final velocity. It will start having final velocity when it is coming down. So at this point, it means that our final velocity, which is v itself, is 0 meters per second. What it means, therefore, is that over here, in place of the v over here, if we do the substitution, we're going to have 0 squared is equal to our initial velocity is 30. So we have 30 squared, then minus 2, the gravity is 10, and then we have our height. So from here, I'm going to send this portion. Okay, let me expand that first. So I have 0 squared is equal to 30 squared is 900 minus 20h. So from here, I'll send the 20h to the other side of the equal to sign. Okay, because here is still 0. So I'll send that. If I do that, I'll have 20h is equal to 900. So to find my height, I'll divide both sides by 20 by 20. So this will cancel this. So the height here will be, the 0 will cancel 0 here. The 2 will divide 90 45 times. So 45 meters becomes my height. So now that I have my height, it's easy for me to find the potential energy, as the potential energy now is equal to mass multiplied by the gravity multiplied by the height. So which is therefore equal to, the mass is 0.5 kilograms multiplied by the gravity. The gravity in this case is 10. Then the height, which we just found to be 45. Okay, so from here we have 0.5 multiplied by 10. That will be half of it. So we have 5 over here. And then that 5 will multiply the 45 we have over here. And then that will give us the potential energy of 5 multiplied by 45. That will give me 225. So 225 joules is my answer. And if I look through the possible choice questions, option B here is the correct answer over here. So over here, the key is that you use the formula of linear motion. Okay, we use this formula to find the height first, and then after finding the height, we can now proceed to calculate for our potential energy. All right, let's proceed to look at another example. So we have over here a body of mass 50 kilogram is lifted vertically to a height of 10 meters. We are to calculate the minimum amount of work done, given that gravity is 10 meters per second square. And this is the SSE 2002 question number 12. Here are our possible choice options. We have option A, 250 joules, option B, 500 joules, option C, 2500 joules, and then option D, 5000 joules. All right, so let's proceed to look at the solution to this problem. And as always, the first thing I will do is to write down the parameters that I have in the question. And that is a body of mass at 50 kilogram. So that means my mass is 50 kilogram. And then it has been lifted vertically up to the height of, so my height is 10 meters. And then I am to calculate the minimum amount of work done. So I'm supposed to find work, which I do not know. And then my gravity has been given to me as 10 meters per second square. All right, so now to calculate work done is equal to the product of force times distance. Okay, the distance traveled by the object. Now, force itself is mass times gravity, and because this was lifted upward, the gravity over force times acceleration. Force is mass times acceleration. So force is mass times acceleration. But because this was lifted up, the acceleration will not be due to gravity, so it is mg. And then the distance it has traveled is the distance vertically upward, so that becomes the height. So our formula is mgh for work done, which is mass multiplied by gravity multiplied by height. We already have our mass, we have our height, we have our gravity, so we just multiply everything after substitution. So I have here the mass, which is 50, multiplied by gravity, which is 10, multiplied by height, which is also 10. So therefore, my answer will be 5. Then I just add the 3 zeros. Then I add this to it. So it's 50, then I add the 2 zeros, so it's 5000 joules. So my final answer, or my work done is equal to 5000 joules. Now, if I look through my possible options, option D is the correct answer for this particular question. Okay, so thank you so much for watching. This is how we solve some past question on work, energy, and power. We'll be looking at more questions later in the future. So if you like this video tutorials and you want to see more, subscribe to my science tutorials, turn on the notification button, share the video, and don't forget to like. Are you okay? All right, thank you once again, and I will see you in the next video. Bye bye.